So I started teaching a class modestly called How to Make Almost Anything. And that wasn't meant to be provocative. It was just for a few research students. But the first day of class looked like this. Hundreds of people came in begging, all my life I've been waiting for this class. I'll do anything to do it. Then they'd ask, can you teach it at MIT? It seems too useful. And then the next surprising thing was they weren't there to do research. They were there because they wanted to make stuff. They had no conventional technical background. At the end of a semester, they integrated their skills. In turn, $20 million today does this. 20 years from now, we'll make Star Trek replicators that make anything. The students hijacked all the machines I bought to do personal fabrication today. When you spend that much of your money, there's a government requirement to do outreach, which often means classes at a local school, a website, stuff that's just not that exciting. So I made a deal with my NSF program managers that instead of talking about it, I'd give people the tools. This wasn't meant to be provocative or important, but we put together these Fab Labs. It's about $20,000 in equipment that approximate both what the $20 million does and where it's going. A laser cutter to do press-fit assembly of 3D from 2D, a signcutter to plot and copper to do electromagnetics, a micron scale, numerically controlled billing machine for precise structures, programming tools for less than $1, 100 nanosecond microcontrollers. It lets you work from microns and microseconds on up. And they exploded around the world. This wasn't scheduled, but they went from inner city Boston to Pabal in India to Sekondi Takoradi on Ghana's coast to Soshanguve in a township in South Africa to the far north of Norway, uncovering or helping uncover, for all the attention to the digital divide, we would find unused computers in all these places. A farmer in a rural village, a kid needs to measure and modify the world, not just get information about it on a screen, that there's really a fabrication and an instrumentation divide bigger than the digital divide. And the way you close it is not IT for the masses, but IT development for the masses. So in place after place, we saw this same progression, that we'd open one of these Fab Labs, or we didn't, this is too crazy to think of. We didn't think this up, that we would get pulled to these places. We'd open it. The first step was just empowerment. You can see it in her face, just this joy of I can do it. This is a girl in inner city Boston who had just done a high-tech on-demand craft sale in this inner city community center. It goes on from there to serious hands-on technical education informally out of schools. In Ghana, we had set up one of these labs. We had designed a network sensor, and kids would show up and refuse to leave the lab. There was a girl who insisted we stay late at night. Her first night in the lab, because she was going to make the sensor. So she insisted on fabbing the board, learning how to stuff it, learning how to program it. She didn't really know what she was doing or why she was doing it, but she knew she just had to do it. There's something electric about it. And this was late at 11 o'clock at night. And I think I was the only person surprised when what she built worked the first time. And I've shown this to engineers at big companies, and they say they can't do this. Any one thing she's doing, they can do better, but it's distributed over many people and many sites, and they can't do in an afternoon what this little girl in rural Ghana is doing.
My name is Valentina Kofi. I am 8 years old. I made a stacking board.
And again, that was just for the joy of it. Then these labs started doing serious problem solving. Instrumentation for agriculture in India, steam turbines for energy conversion in Ghana, high-gain antennas and thin client computers. And then in turn, businesses started to grow, like making these antennas. And finally, the labs started doing invention. We're learning more from them than we're giving them. I was showing my kids in a Fab Lab how to use it. They invented a way to do a construction kit out of a cardboard box, which, as you see up there, that's becoming a business. But their design was better than Saul's design at MIT. So there's now 3 students at MIT doing their theses on scaling the work of 8-year-old children because they had better designs. Real invention is happening in these labs.